Hello everyone. So let's continue with the problems. So the fifth question, a vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, one fourth of the water flows out. Find the number of lead shots dropped in the vessel. Okay. So first, let's take a cone. Okay. Usually, when it's a cone, we draw it in this manner, isn't it? So very clearly, they've mentioned it is an inverted cone. So let's draw it. Let's say this is the inverted cone, which is like a bucket. Okay. Now, this is completely filled with water. Okay. It is completely filled up to the top, is up to the brim. It is filled with water. Okay. Now, the dimensions of this inverted cone is the height is 8 centimeter and the radius of the open end it is 5 centimeter. Okay. And there are two radius. One radius is the radius of the cone and the other one is the radius of the sphere. So let me take RC, or let me take capital R, where capital R is the radius of the cone, which is bigger. Okay. Let's take the small r as the radius of the spheres, which is 0.5 centimeter. Now, what happens if we drop, it is completely filled, this bucket is completely filled. If I drop some lead balls, that is lead spheres, okay, what happens? Definitely the some amount of water flows out, isn't it? Some amount of water will flow out, isn't it? Now, according to the question given, the volume of water flown out, volume of water flown out is given as, the volume of water flown out is given as one fourth of volume of the total water. So volume of the water, let me write it in the next line. One fourth of the volume of the water in the bucket, or let's say in the vessel. Okay. Now, very clearly, now if you observe earlier in this place, what did you have? We had water, isn't it? Now, as soon as you drop some ball, lead balls, the water flows out, isn't it? The water flows out. Now, it's very simple. Now, whatever the water has occupied the space, okay, that space is occupied by the lead balls, isn't it? Earlier, we have got this, let's say this is lead number 1. Okay. Now, if it was not there, what would have been there? Water, right? Now, instead of this water, we have got a ball here. So very clearly, the volume occupied by the lead balls is actually equal to the volume of the water that is gone, isn't it? Whatever the space the balls has occupied, that amount of space, that amount of water has gone out, isn't it? Otherwise, the ball couldn't have fit in, isn't it? So very clearly, volume of water flown out, volume of volume of let me write it properly, volume of water flown out, that is actually equal to the volume of total volume of the lead balls, isn't it? Total volume of lead balls, all spherical balls or lead shots. Okay. Now, volume of water flown out, as we know, it is one fourth of volume of the water in the vessel. Volume of water in the vessel will be equal to what? Volume of the cone itself, isn't it? So let me write volume of cone. So 1/4 into volume of cone, and total number of the total volume of lead shots. What we can do is we'll find the volume of one lead shot, which is a sphere. Okay, volume of sphere. Okay, multiplied by the total number, that is n. Okay, let's find volume of one lead shot, which is a sphere. Okay, so I've taken volume of sphere into n, the total number. So n represents the total number of lead shots. The next step, let's substitute 1 by 4 into volume of cone. Volume of cone is 1 by 3 pi capital R square h. Okay, remember capital R is the radius of the cone. N into volume of sphere is 2 by 3 pi small r cube. Okay. Now here are the things that we can cancel. What we'll do is this 4 and 3 which are in the denominator, let's send it the other side. So here you will be left with pi r all pi r square h, that will be equal to n into 2 by 3 pi r cube into 4 into 3, isn't it? Because the 4 and 3 were in the denominator, so we have sent it the other side. 3 gets cancelled. Also pi and pi gets cancelled both the sides. So we'll be left with r square h is equal to n into 2 into r cube into 4. Okay. So r is 5, right? 5 square h, the height of the cone. The height of the cone is how much? 8 centimeter. So let's take it 5 square into height 8, n into 2 into r cube is 0.5 cube. So 0.5 into 0.5 into 0.5. Okay. Into 4. Okay. So the next step, 5 square is 25 into 8 is equal to n. Now observe 2 into 0.5 becomes what? 1. So 2 into 0.5 is 1. 0.5 into 4 is 2. Okay. Again, that 2 into 0.5 becomes 1. Okay. So basically, if you multiply all those things, you will end up with 1. Okay. Let me do it and show you. 2 into 0.5 is how much? 1. So 1 into 0.5 is 0.5 itself. Now this 4 into 0.5 is 2. So here the answer was 1. 1 into 2 is 2. Okay. So you will end up with the answer 2. Now what we need is the value of n. Okay. So let's send 2 to the other side. 25 into 8 divided by 2 is equal to n. 2 ones are, 2 fours are. 25 into 4 is 100. Therefore, the value of n is 100. Therefore, how many lead shots were dropped in? Totally 100 lead shots were dropped. Let's get into the next question. A solid iron pole consists of a cylinder of height 220 centimeter and base 24 centimeter. Sorry, base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cube has 8 gram mass. Okay. So initially there is a cylinder. Okay. Let's take this as a cylinder. This seems to be a big cylinder. Okay. So let's take the dimensions as capital R and capital D, capital H. The height is 220 centimeter and the diameter is 24 centimeter, which implies the capital R will be 12 centimeter. On top of this, we have got one more cylinder. Okay, something like this. Okay, so here let's take it as small h, which is 60 centimeter, and the small r is already given as 8 centimeter. We have to find the mass of the total solid. For that, we have to find the volume. Okay, because 1 centimeter cube, okay, is 8 gram. So we have to find what is the total volume occupied by this. For 1 centimeter cube, it is 8 gram. If you calculate the volume, easily we can calculate the mass. So volume of solid is very clearly volume of bigger cylinder, plus volume of smaller cylinder. The volume of bigger cylinder is actually pi capital R square capital H plus volume of the smaller cylinder pi small r square small h. Now what is common? Pi is common. What is the value of capital R? Capital R is 12. So 12 square. What is capital H? 220 centimeters plus small r is 8 square and small h is 60. So pi is 22 by 7 as it is. Okay. 12 square is 144 into 220. 8 square is 64 into 60. Okay. So we get 22 by 7. 144 into 220. That comes around, if we calculate it, 11, 31680. 31,680 plus 6 4s are 24, 6 6 are 36, 38, 3,840. Okay. So 22 by 7 into this comes around 0, 12, 9 plus 6, 15, 2, 2 plus 3, 5. So 35,520. Okay. So this is the volume of the solid. Let's not multiply. Let's keep it as it is. Volume of the solid is so much. Okay. And remember here, we are not supposed to take pi as 22 by 7. They've given it as 3.14. So let's take it as 3.14 itself. Okay. Now, this is the volume of the solid. So mass will be equal to mass of the solid. Mass of solid. For 1 centimeter cube, it is so much. For so much centimeter cube, what should we do? We have to multiply by 8. That's it. 8 into 3.14 into 35,520. If you multiply so everything, we get it in grams. You can also convert it into kg. Okay. So let's get into the next one. In the next question, a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter, standing on a hemisphere of radius 60 centimeter, is placed upright in a right circular cylinder full of water, such that it touches the bottom. Find the volume of the water left in the cylinder if the radius of the cylinder is 60 centimeter, height is 1 centimeter. Now listen, there was a cone. Okay. The dimensions of the cone are given. Okay. Which is mounted on a hemisphere, something like this. Okay. And there is another cylinder which is completely filled with water. Okay. Which is completely filled with water. Now what we are doing is we are placing this cone, okay, inside this cylinder. Okay. So we are taking this structure and we are placing here. Okay. Something like this. Okay. Now obviously when you place it inside this, definitely some amount of water flows out. And remember, the volume of water flown out, that will be equal to volume of the thing that has come in. That is the volume of the solid. Okay. So whatever is the volume of water that is flown out, that will be equal to the volume of solid, isn't it? So very clearly, volume of water flown out, please remember this. The amount of water that is flown out, that will be equal to the amount of thing that has come in, isn't it? So here the amount of thing that has come in is equal to volume of solid. Okay. Now the question is, we have to find the volume of the remaining water. Okay. So volume of remaining water, that will be actually equal to, first let's find what was the volume of water earlier. It was equal to the volume of cylinder, isn't it? Earlier, before placing the solid, it was equal to volume of cylinder, isn't it? When you had the cylinder completely filled with water, then some amount of water flown out, isn't it? So volume of remaining water is equal to what was the water that was earlier, okay, minus the water flown out. So what was the water that was earlier? It is volume of cylinder. What is the amount of water flown out? That is equal to volume of solid, isn't it? So what you add and what left. So earlier the cylinder was completely filled. So the complete amount of water is equal to volume of cylinder. Now some amount of water flown out. What is the amount of water flown out? That is equal to volume of solid. If you subtract these two things, you get the volume of remaining water, isn't it? Now let's write the dimensions. Okay. And if you observe carefully, the radius of the cylinder and the radius of the cone and the radius of the hemisphere are same. So I'm going to use only one r. I'm going to denote by small r as 60 centimeter. All the radius of cylinder, radius of cone, radius of hemisphere, everything is same. Okay. And the height of the cone is 120 centimeter. Okay. That is from here to here. It is 120 centimeter. And the height of the hemisphere is, or the radius of the hemisphere is 60. So the total height is 180, isn't it? So the height of the cone is 120, but the total height of the solid is 180. That is actually equal to the height of the cylinder. Okay. So let me take HCy, height of the cylinder, which is 180 centimeter, and HC, that is the height of the cone, which is 120 centimeters. Okay. I hope this is clear. So let's get into the question. Volume of cylinder. Volume of cylinder is given by the formula pi r square HCy minus volume of solid. Now, solid is made up of two parts. So let's write the bracket. It has got cone and hemisphere, isn't it? So what is the volume of cone? Volume of cone is 1 by 3 pi r square HC. Okay. Plus volume of solid, it has got two things, right? Cone and hemisphere. So that's why we are writing inside the bracket. This is volume of cone plus volume of the hemisphere. That is 2 by 3 pi r cube. Okay. Now, let's remove the bracket. So it becomes pi r square HCy minus 1 by 3 pi r square HC minus 2 by 3 pi r cube. Isn't it? Now, let's try to take common here. Now, what is common? If you observe carefully, throughout pi r square is common. So the left out thing is HCy minus 1 by 3 HC minus 2 by 3 r. Okay. So pi value is 22 by 7 and radius is 60. So 60 square. Height of the cylinder is 180 minus 1 by 3. Height of the cone is 120 minus 2 by 3. The radius is again 60. So here we can cancel it. 3 ones are 3 40s are 3 ones are 3 20s are. Okay. So 22 by 7 into 60 square is 3600. 180 minus 40 minus 2 into 20 is minus 40. So let me continue here. That will be equal to 22 by 7 into 3600. 180 minus 40 is 140. Again, 140 minus 40 is 100. Okay. So this becomes 22 by 7 into 36. Okay, 3600 into 100. So two more zeros. So it will become 3,60,000. Okay. So if you multiply this and divide by 7, you get the answer. So 22 by 7, you can roughly take it as 3.14 into 360000. So if you remove the decimal, it will become 314 into 3600. Multiply this, so much centimeter cube. That's the volume of the water that is left in the cylinder. So let's get into the next question. In the next question, a spherical glass vessel has a cylindrical neck. A spherical glass vessel, okay, spherical glass in the sense something like this, which has a cylindrical neck, then it will be something like this. You can also say it as a spherical flask, okay, kind of a conical flask, something like this. Okay. Now, the question is, neck 8 centimeter long. Okay, the neck, the cylindrical neck is 8 centimeter long, which means height of the cylinder is 8 centimeter. Remember that. And 2 centimeter in diameter. The radius is 1 centimeter. If the diameter is 1 centimeter, 2 centimeter, radius will become 2 centimeter. The diameter of the spherical part, okay, let me take it as capital D, which is 8.5. So capital R will become 8.5 divided by 2 centimeter. That's the radius of the sphere. The smaller r is the radius of the cylinder. Okay. By measuring the amount of water it holds, a child finds it the volume to be 345. We have to check whether she is correct or wrong. Okay. So water, this setup or this vessel is completely filled with water. We have to find the volume of water inside. So volume of water that will be equal to volume of cylinder, because the cylinder also consists some amount of water, isn't it? Volume of cylinder plus volume of sphere, both put together is the volume of the water in the vessel. So volume of cylinder is given by the formula pi r square h. Volume of sphere is 4 by 3 pi capital R cube, because we have taken capital R as the radius. Okay. So in the next step, you can take pi as common. Okay. R square, that is small r, that is 1 square, h is 8. Okay. Plus 4 by 3. First, let's write the remaining things. If you take pi as common, left out thing is r square h plus 4 by 3 capital R cube. Okay. So in the next step, pi value is 3.14. Small r is 1, h is 8 plus 4 by 3 capital R cube, that is 8.5 by 2 the whole cube. So we have to write it thrice. 8.5 by 2 into 8.5 by 2 into 8.5 by 2. Okay. So here 3.14 as it is, 1 square is 1, 1 into 8 is 8. So let's cancel 2 ones are, 2 twos are, again 2 ones are, 2 ones are. So there is no other further thing that gets cancelled. Okay. So 8.5 into 8.5 into 8.5. 8.5 into 8.5, you get it as 72.25. Okay. Into 8.5 divided by 3 twos are 6. Okay. So let's simplify this. Let's try to cancel 6 ones are 6 ones are 6, 1 carry, 6 twos are 12. Okay. Point as it is, you cannot divide it directly, so you'll take a 0 and you'll take 2 digits. 6 fours are 24, 1 carry, 6 ones are 6, so it is roughly around 12.041. Okay. So 3.14 into 8 plus 12.041 into 8.5. So multiply these two things. So 3.14 into 8 plus 12.041, 12.041 into 8.5, that will be equal to 102.3 plus 8, so it will become 110. Okay. So the total one, if you add it, it will become 3.14 into 110.35. Okay. So if you multiply this with 3.14 into 3.14, okay, this comes around 346.49. Okay. But what did the child find it as? 345, but what we have got it as 346. They are not same, right? Therefore whatever the child has found, it is wrong. Therefore the correct volume is 346.49 centimeter cube. So this is how we verify. So with this, we have completed the second exercise. In the next video, we'll start with the third exercise. Thank you, students.